I think the easiest way to start off with this problem is figuring out the concentration of the magnesium nitrate in our original solution. So before we've diluted anything. So I want to start with 37.1 grams of MgNO3 2. And I want to convert this to moles. And the molar mass of this compound is 148.33 grams of MgNO3 2 per 1 mole. And then to figure out the concentration, or in terms of the molarity, I can just say 1 here and then divide this by the volume, which we know is just 1 liter, because we said that 1,000 milliliters is just 1 liter right here. So if I go and do this math, this gives me 0.250 moles. So that is the original concentration of the solution we have before we've diluted anything, before we've done any adjustments to it at all. Next, it says if we remove 20 milliliters of the solution and then dilute this 20 milliliter sample until the new volume equals 500 milliliters, what is the concentration of Mg2 plus in the 500 milliliter solution? So I think one of the easiest ways to do this is using the dilution equation. So we know that the dilution equation is M1V1 equals M2V2, right? Now, we know that if we remove 20 milliliters of the original solution, then the concentration stays the same, right? So our M1 right here can be 0.250 molar, right? And our V1 can just be 20 milliliters, which is 0.02 liters. And then we can set this equal to whatever our new M2 will be. This is our new molarity. So new molarity. And I didn't mean that equals there. And set this equal to our desired volume, which they said was new volume equals 500 milliliters, which is just 0.500 liters. So now to solve for M2, we just rearrange. So M2 would equal 0.250 times 0.02 liters. And always remember to write down your units because it helps you not get confused. Liters cancels. And we should be left with, let me do the math really quick. 0.2 divided by 0.5. 0.01. I'm just going to say, well, yeah. I'm just going to say 0.01 because to me that's easier. So 0.0001 molar of MgNO3 2. Now, what's interesting here is that what they ask for are the concentrations of the individual ion species, right? So if we have 0.01 molar of magnesium nitrate, MgNO3 2, that's not our concentrations of magnesium and nitrate. Those are different. So one of the things we have to look at is we can look at the chemical formula of our compound and then determine our concentration from that. So if I have 0.01 molar of magnesium nitrate, that equals 0.01 moles of that compound of MgNO3 2 per liter, right? Now, if I wanted to look at these moles, I could just multiply this and say, hey, for every 1 mole of MgNO3 2, I have 1 mole of Mg2 plus, because in the formula there's only 1 magnesium, which means that my concentration of Mg2 plus is also going to be 0.01 molar. Now, if we apply the same logic to the nitrate ion, we see that this has a number of 2, right? So if that's 2, it has twice as many moles of nitrate than magnesium, right? Because there are 2 nitrate molecules per 1 magnesium molecule according to our formula. So then the nitrate concentration is 0.02 molar.